Hi, in this video we're going to introduce what we'll refer to as classical image segmentation. You'll learn about images and image features and how to segment based on those features. While this knowledge is useful in its own right, you'll also need this knowledge to understand the later lessons in this course. Hi, let's get started on the classical image segmentation part of this module. So let's place this lesson into context within the overall course. We'll remind ourselves that our ultimate goal is to demonstrate that deep neural networks at the moment really offer stunning image segmentations. And we're going to harness these techniques effectively ourselves. So overall, we're building towards that goal. In the previous lesson, we looked at image classification, and now we're going to see how we can place image segmentation on top of image classification. So now we need to familiarize ourselves with some classical image segmentation techniques. Firstly, these are very useful in and of themselves, and secondly, the concepts we'll work through here, for example, convolution and image features, are used in the deep neural network modules as well. So this will also tee us up nicely for the next module in neural network-based image segmentation. So in this lesson, we will gain enough knowledge about image segmentation to understand its importance and some of the myriad of application domains that require image segmentation. You will learn how to analyze an image in terms of its features, for example, color, intensity, and things like edges and corners. You will gain an appreciation of common approaches you can bring to bear on a particular problem, and gain insight into what approaches pay dividends with what types of image. You will know that there are a couple of well-known families, ranging from relatively simple but useful techniques such as image thresholding through to more complex families such as clustering, region growing, and other families such as template matching and edge detection. Between this module and the associated labs, you can develop your own simple projects using thresholding to segment a simple image, or clustering to segment an image, or using the watershed algorithm to segment an even slightly more complex image. As we go along, I'd hope that you'd also take notice of what types of images tend to expose the limitations of these algorithms. So, for those of us who need an introduction, or possibly a refresher, there's a mini lesson with some introductory material. For those of us comfortable with representing images as matrices and operations such as dilation, convolution, etc., please feel free to skip over that section. Segmentation is non-trivial, being amongst the hardest in image processing, with lots of algorithms normally based on discontinuities or similarities, the opposite of discontinuities. Generally speaking, there is no widely accepted unique method or approach for image segmentation. Don't quote me on this, but I think I read recently there are in the order of 3,000 algorithms available for image segmentation, and it's still an area of active research. So in this module, let's limit ourselves to looking at 5 major families of classical image segmentation algorithms and zoom in on 4 algorithms which we'll use in our lab work on some real-world projects. Oh, and don't ask me to define classical. I think of it as the standard corpus of image segmentation techniques prior to the introduction of neural network-based techniques around roughly 2012. In later lectures, we'll discuss some of the newer neural network-based approaches. These algorithms, and we'll see this for ourselves in later labs, they offer significant improvements in segmentation, but they require significantly more resources to run. So that leaves the classical approaches very relevant, particularly when working on simpler images, or when working in constrained resource contexts. For example, when your design has relatively low processor capability, relatively low memory, or if you've got bandwidth constraints. Okay, you should have an understanding of what this part of the course will consist of. Please remember to do your lab work at the end of each section.